Well, hello, Team OOP. Welcome to the first video in this series. Um, I am going to start the series with a video about OOP, introduction to OOP using Java. Now, this video is not about the basics of Java, or how do we run Java, how do we execute Java, all these elements, how to create variables. This is again not a basic class. I'm assuming that you already know a lot about Java, and you would like to learn about using Java to create projects using OOP style of programming. So, by the way, OOP is basically a shortcut for object-oriented programming, just in case you don't know. So here's some assumptions that I'm going to make before I start talking about anything. I know that I'm going to assume that you know how to use Eclipse, because that's basically what we're going to be using here. And if you want to use any other Java IDs, then go for it. I don't have a problem with that. I'm going to assume that you already know how to create a Java project and how do you run it. And I'm also going to assume that you know the basics of Java programming, the syntax of Java, variables, identifiers, data types, string processing, keyboards, comments, expressions, operations, selection structures, repeating structures, method, references, arrays, files, input, output, and a lot more basics of Java. So I'm assuming that you know all of those concepts. But at the same time, whenever we deal with one of those cases, I'm just going to mention it or explain it really, really briefly. Again, just to help you out if you don't really remember it very clear. So those are the assumptions. In this video, I'm going to talk about what is OOP, what are classes and objects, getters and setters, constructors, the toString method, arrays of objects, garbage collector, and the Java library. So those topics are going to be covered in this video today. We are going to have a case study where I am going to use an example where I'm going to use this example to demonstrate the concept of how to create classes and how to use those classes to create objects out of them. So the first very part of this lecture or this video is basically just going to be about talking about object-oriented programming, and then after that we're going to be moving on to Eclipse, and then after that we might go back to this PowerPoint file. Let me just maximize this. Come on, here we go. So let's start with the question, what is object-oriented programming? Well, here's object-oriented programming is it's the other type of style programming, and before object-oriented programming, we used to create projects and run and create programs using what we call procedural programming. And procedural programming basically means that when you have a project, you treat that project as a series of blocks, and each block by itself is responsible of performing one task, and we call those blocks functions. So your big project basically is going to be divided into those functions, and then you call these functions in a certain order to get a problem solved. Object-oriented programming basically think about solving problems in a different way. And instead of looking at the whole thing as one unit, we basically treat the problem the same way your brain treats everything around you. You get into a room, all you see is, let's say, chairs, furniture, fans, TVs, couches. Every single one of those that I just mentioned are basically what we call objects. And those objects basically interact with each other to get something done. So with object-oriented programming, we no longer look at the problem as a sequence of steps that your program is basically going to follow to solve a problem. And instead of that, we put that on the side. That's the main goal, again, to solve the problem. But we put the design in steps in the side, and we just think about the problem in a form of objects. and we try to solve this problem using those objects. So if I want to think about a problem, for example, if you have, let's say, for example, you have your car, and your car basically is not working. So you want to solve this problem. Well, procedurally, what you would do, you would think about, well, I'm going to do step number 1, step number 2, step number 3, check the battery, check this, check that, and then if I find a problem here, this is what I'm going to do. If I find a problem here, this is what I'm going to do, and all these kind of details. That's basically procedural thinking. Now, if you think about object-oriented programming, you leave the problem why the car is not working at the first time, and you just think about it as, oh, I got a car. A car is an object. Well, how do I describe this car? Well, this car is described by 1, 2, 3, 4. And what does this car can do? This car can do 1, 2, 3, 4. And then after you're done with all of that, now you think about the problems, and then you will see that you will have a method in that class that you just created for that object to solve this problem of what if the car is not working. So bottom line here, what I'm trying to say here, object-oriented programming is a way or a method of writing or creating projects where we think about the problem as objects, and those objects interact with each other to solve that problem. That's basically what object-oriented programming concept is. Now, if you look at the graph that you see here, the benefits of object-oriented programming is basically, or the main concept of object-oriented programming is that you're going to sit and you're going to design a class for the object, and the design by itself is considered as the blueprint. And just like people at manufacturers, they're trying to, let's say, create computers, consoles, TVs, electronic devices. Before they start the process of manufacturing those devices, they will have the design phase, and the design phase basically will end up having what we call the blueprint. And object-oriented programming, you're going to create the class, and the classes basically represent the blueprint. Right after you get the class, you get the design, everything is studied, everything is okay. Right after that, you're going to start creating objects, multiple objects, not only one object, multiple objects that belong to the class, in this case, car. And that's basically what object-oriented programming is. Basically, you write a class. In this class, you're going to define everything related to the car in this example. The color, the speed, the size, the type, the module, all these details is going to be defined inside that class. And then after that, you're going to use that blueprint or that class to create multiple different objects that all of them belong to the same class, even though there are different types of cars, but at the end, they are all cars. So that's basically what object-oriented programming is all about. Now, why should I learn object-oriented OOP? Well, basically because this is how the world is running. Every single company in this field is basically using object-oriented programming. I don't know if anybody's not using any object-oriented programming style in their code. And why do people use object-oriented programming? You may think that it's way more complicated than the procedure. Procedure is a lot easier. So what is the benefit of using object-oriented programming? Well, the benefit is there's a lot of benefits. Let me just put it that way. Number one, it fits perfectly for teamwork. Like, for example, if I want to create, let's say, a video game, and in this video game I will have 10 different classes, well, I can give every single employee a class and ask them to work on it. Now, the good news is they don't need to interact with each other at the beginning. Like, this is your responsibility, this is your class, get it done. Don't worry about whatever everybody's doing. Just worry about your class. So I can divide my work into those groups. That's one of the benefits. Benefit number two, having your project in a single unit makes fixing errors and debugging and updating very, very complicated. But when you divide your big project into smaller classes, and then if you find a problem in one of the classes, then all the other classes are okay. All you have to do is just focus on that class that has a problem and fix it there. And even that class basically is divided into smaller units, which make the process of updating and fixing errors is a lot easier. Now, another question, why Java? Why not other programming languages? Well, basically, Java is very, very popular. Java is an independent platform or programming language. That basically means your project will work on any operating system, and you don't have to worry about having a different version for every single operating system. It's a little bit slower comparing to C++, but these days computers are very fast, so nobody cares about speed that much anymore. Still, Java is not a perfect fit for real-time applications because it's not as fast as C++, but still, in general, Java is a good choice. It's so good that Microsoft had to come up with their own version of Java, and they call it C#. And C# is it's a good programming language. It's like the twin sister of Java, or brother, if you will. The only difference with C# it only works on Windows operating systems. Recently, now you can run Visual Studio on C# on Mac. That's what I saw a few days ago. But Java again, yep. Java is easy to understand and to learn. Their syntax is not that complicated, but the biggest problem with Java, I will say, it has a huge library, and learning about these libraries is not the easy thing to do. Which again, you don't have to learn everything about them, but as you go, as you learn, as you move on in the process of learning Java, you'll find yourself in a need to learn more about these libraries, and every time you need to learn about a new library, all you have to do is just go study that library, which is, again, it's not that big of a deal. Now, if I want to summarize what object-oriented programming is all about, this graph here will tell you what is it. Object-oriented programming is all about objects, classes, inheritance, encapsulation, abstraction, polymorphism, attributes, and methods. This here summarizes what is object-oriented programming. Now, you, as a programmer or a person who's interested in learning object-oriented programming, you need to understand the meaning of all of those concepts. Now, I do have it explained here with a lot of details, but I'm going to stick with the graph here. So, let's start with attributes and methods. Procedural programming is basically built on attributes and methods. What does that mean? You have a problem and you try to solve it. With procedural style of programming, you're basically going to define variables, and then you're going to use those variables those variables to store data. You're going to process the data, and then you're going to get outputs. Usually, methods are used to process the variables or the data stored inside those variables. Now, object-oriented programming basically will put together methods and attributes in one unit, and that unit basically called class. So when you put variables and you put methods together in one unit, you basically get yourself a class. So a class is basically attributes plus methods. Now, when you hear the word attributes, just think about them as variables. And when you think about methods, it's basically functions or behavior. Now, to understand this a little bit better, I will say class called student. Now, attributes basically are going to be variables that you're going to store data that will define a student. Doesn't matter whose student is that, but it's just variables to store data that's going to be used to define a student. Like, for example, ID number, or name, address, grades, courses, degree. Methods basically are functions that you are going to use the attribute, and those functions are going to process the data of the attribute to get something done. For example, I want to see if that student passed a class or not. I can have a function called pass, and I'm going to use the attributes of that student to figure out if that student passed or he didn't pass. I can have a function to decide if the student will be moving on to the next level or not, based on the attributes that will define that student. So methods basically are functions that's going to use the data stored inside those attributes to get some results or to make some decisions. Now that we have the attributes and the methods, we put them all together, you get yourself a class. Out of that class, you can basically create objects. I can create 5 students, 6 students, 100, 1,000,000 or so students if I want. Each student will have, let's say, an ID number that's different than the other. Will have a name that's different than the other. Will have an address that's different than the other students. So this is basically what objects. Remember, the relationship here is the class by itself is a blueprint, the mask that you're going to use to create multiple objects. Every single object by itself is different than the other objects, but they basically have the same attributes, and they can behave and finish and complete the same methods and call the same methods. So basically, an object, let's say student number 1 will have attributes, student number 2 will have attributes, same data type of attribute but different values. And when I'm going to call a method, for example, pass, student A can pass and student B will not pass, for example, based on the values of the attributes. Now, for the inheritance and encapsulation, abstraction, and polymorphism, we will have a whole video to talk about inheritance, and then we're going to have another video to talk about polymorphism, but I'm just going to give you an idea here about what are those concepts. Inheritance basically means, by itself, it's defined as creating a new classes using classes that already exist. Now you may ask the question, well, how is that possible? For example, if I have a class called animal, and I have another class called fish, the fish is an animal. So a lot of attributes that I have in the class animal will be repeated in the class fish. And a lot of the methods that I have in the class animal will be repeated in the class fish. So instead of repeating the same method and same attributes in the class fish, I will let fish inherit from animal, and basically inherit from an animal class basically means you are creating a new class using a class that already exists. Usually we think about inheritance as one class is going to be a more generic class and the other one is basically more specific class. Like animal is more generic, fish is more specific class. But that's not the only case, of course. Polymorphism, on the other hand, the concept by itself is a little bit more complicated than inheritance, and a lot of people find it really, really hard to understand. But I'm just going to give you an idea here, so you'll understand it. I can have a class called person. Now I can create an object out of that person, and let's call it person A. Now, person A by himself, he could be a father and act as a father. He could be a teacher and act as a teacher, and he can be an employee and he can act as an employee, and he could be a son and act as a son. So you can see that we have one object that belongs to one class, but he can act in multiple different ways. He could be a father, he could be a son, he could be an employee, he could be an athlete, he could be a lot of different other classes, objects that belong to different classes, and those classes basically belong to, like, for example, a father is a person, an employee is a person, a son is a person, an athlete is a person. You see that all of those are classes at the same time, and they all belong, and they are also belong to a class, a more specific class, which is, for example, the father, and more generic class, which is the person. Just like the fish. Fish by itself, if I create an object called goldfish, goldfish belong to a class called fish, but at the same time, goldfish belong to also to a class called animal. So this is basically what we mean by polymorphism. How can I have an object that belongs to one class specifically, but it can act as different other objects that belong to different classes, even though there should be a relationship between those classes, by the way. Just like I said, a father is a person. You cannot expect a person to act as a robot. There's no relationship here. Now, that's basically what we mean by polymorphism. Now, encapsulation and abstraction. Let me just go to the definitions here that I have. And I will get to those abstractions and encapsulation at the end here. So let's go back here and stop. For example, class is an object. Well, classes are extensible program code template, just like we said, a blueprint to create objects. And we define the state of those objects using those classes, implementation of the behavior of it. Class is the blueprint, as I said, for creating objects. Now, every single class is defined by the attributes and the methods. Attributes are the variables. Methods are basically procedure or functions of that object. Now, composition is a concept we're going to talk about, of course, later. And just to give you an idea of what composition means, I am a person, and I belong to a class called a person. I'm an object. Let's call me P1. And I belong to a class called person. And at the same time, I have a car. A car belongs to a class called vehicle. So there's a relationship between me and my car. I have a car. So the car is basically going to be a member of the class person. That person has a car. That's basically what we mean by composition. And we're going to talk about that a lot later in the next videos. I talked about inheritance. I talked about polymorphism. Now, information hiding and encapsulation, a lot of people get confused to understand what's the difference between them. And I am going to go and start talking about encapsulation, so after that we'll get to the information hiding. The idea of having data and methods united in one unit, that's basically what we mean encapsulation. So the process of putting the methods and the attributes all together in one unit, that's basically what we mean by encapsulation. And encapsulation, one of the very, very important features about encapsulation is basically information hiding. Now, what is information hiding then? Well, whenever you create a class, you are going to try to hide the details from the users. You don't want them to have access to it for many, many reasons, and I'm going to talk about them right now. But encapsulation and information hiding, basically, if I simplify it enough, let's say you work for a company and you have a job that you have a client, and this client basically came to you and he told you that I have a problem called X. So what are you going to do? You're going to go ahead and study the problem X, try to figure out how do you solve that problem. And you're going to create a class, and out of that class, let's say this class that you're going to create basically contain, let's say, 100 of methods and contain hundreds of attributes. Now, your job is basically, whenever you come to your client and you try to represent the solution, you need to hide as much as details as you can from that client. You basically have to tell them, if you want to use this class, you can call this method. And you explain that method to him in a simplest way. Now, all your classes just that method? No, you have 100 of other methods inside it. But your job as a programmer, and you're following information hiding, you hide all these details from the user, so basically you'll make their life easier. Is that the only reason why we hide information from the user? No, not that. That's not only the reason why we do that. A lot of the variables you will have, or attributes you will have in your class, you want to have direct control over what values will be assigned to it. If you keep everything available to users or programs, they may end up changing some values to values you don't want that to happen. I'll give you an example. For example, let's say you're programming a video game and the health of, let's say, a monster has 100 points. As a programmer, you want to make sure that the value would not pass the 100 and would not go below 0. But imagine a gamer can have access to that variable and can change it Well, you know what? I'll just set it to 0 at the beginning. Or let's say you're talking about the health of the player himself. And instead of setting, you're going to set it at the 100 at the beginning of the game, and then it's going to go down as the game goes on. Now, let's say I want to go and I'm a user for that video game, and I have access to that variable. You know what I'm going to do? I'm going to go ahead and put 1,000 instead of 100, so I will never die. Or even if I'm going to die, it will take a long time for me to die. So data hiding, basically, you hide all these variables from the user. They will see it. They can actually see the effect that's going to happen to it, but they will not have direct access to it to change it the way they want it. You have control over how much or how they will be able to change those kind of information. And that's basically what we mean by information hiding. Now, abstraction basically means, let's see here, abstraction. Yeah, abstraction, it's kind of, again, very similar to what I was talking about in encapsulation. Let's say you're trying to build a house, and the house by itself has a lot of details. Abstraction basically means you just show the essential information about the house, and all the other details, they don't need to know them. You don't have to give your client headaches about them. It's your job. It's your responsibility to know them. But you just basically put whatever is important for the client to see in that abstraction. I'll give you an example here. If I'm going to create a system for students at your college, I will have your ID, for example. I will have your name, maybe social security number, and your address. But there's a lot of details about your life that I may not need to know anything about them. So when I'm going to create a class about students, I don't need to list them. For example, your diet. It doesn't have to do anything with your study plan. So I'm not going to put a variable called diet. Or let's say I don't care about how to get to school. So I'm not going to put if you have a transportation or not. And again, if it has to do something with the problem that I'm trying to solve, or it's related to the system, yeah, I will do it. But those attributes that has nothing to do with the problem that I'm trying to solve, now I don't need to put them there in the problem in the definition of the class. So this is basically what those concepts of object-oriented programming is all about. Now, a simple Google search will get you more example and more details about them. I would highly recommend for you to go and study and read more about those concepts, but this is just to give you an idea about those concepts. Now, next what we're going to do, we are going to try to demonstrate the syntax of creating objects. We're going to talk about the system that I'm going to try to create here is called the Patient Registry Management System. We'll go through the design and the implementation. We're going to talk about the UML and how do I create a UML, which is something you need to know. And then I'm going to talk about how do I create the class, how to create object of the class, what are the setters, the getters, constructor, the garbage collector, and we're going to talk about the toString methods. So stay tuned and don't leave. I'll be back in a sec. Welcome back. Now we're going to talk about the problem that I just mentioned a few minutes ago. Which is the patient registry management system that we're going to use as an example to study classes and objects. The first thing I'm going to do is I'm going to go through the design phase. And in the design phase, I'm going to create what we call the UML, which is a shortcut for a Unified Modeling Language. Now, a UML basically it's a table, and in this table you're going to define the class that you're going to create. And there are certain rules that we have to follow. And now, why do we use UML? Well, basically, if you give me a UML for a class, I should be able to understand, let's say, 80% of the class without the need to go in further details just by looking at the UML. So UML will give people an idea about your class in a very, very compact presentation. So the first thing I'm going to do here, you put the class name at the top here. And the class that I'm going to create is called Patient Registry. I'm not using camel case, as you can see here. I'm starting with the uppercase P and registry here, uppercase R. And that's what we do with the name of the classes usually. Now, As you can see here, this table contains 3 rows. The first row is for the class name. The second row is for the private sections of the class, and this is for the public section of the class. Now, we're going to talk about private and public sections later, but just to give you an idea, the private section or private members of a class, other functions or other classes will have no access to whatever you're going to put here, and that this is basically fall under part of information hiding. And what we do usually, we put the sorry, let me just go back to it. This part is basically where we define your variables. And the variables usually are private or attributes. And we use the negative sign to define or to declare that this is a private attribute, or sometimes even methods. So we put the negative here, and then what do we do after that? We tell what is the name of that variable that you're going to create here. For example, I will have a variable called patient ID. Now, after you do the patient ID, you put a colon here, and you tell me what is the data type for patient ID. I will just go with a string. Well, let me just reduce the spacing here because it's way too long. Let me add this to my library. Okay, so I got patient ID. What else do we have here for a patient? Let's say age. And, you know, they always ask for a birthday date, so date of birthday. I can create an object out of that, but for simplicity, I'll just go for a string right now. So we got the patient ID, well, name, of course. So I'll go full name. This is a string again. So we got full name. We got the what else do we put? I'm going to try to simplify it now as much as possible. So I have his birthday, has his patient ID, has his name. I can have his address if I need, his marriage status. You can define as much as variables as you need. But what I'm going to try here to do here, I'm going to try to put a very, very special method here, which is an array. And in this area, I'm going to say problem. And the problem basically is going to be an array and a type of string. Again, most of the variables are string. Now, what I'm going to do here, what I'm going to assume here, and of course you don't have to do the same thing, but I would say in this hospital we can only solve or help patients with 4 different types of problems. And I am going to create an array of these problems, and I'm going to define it as static. So because it's static, I need to put underline here. So whoever's going to read the UML will understand that this is a static array that I'm going to define inside my patient registry. Again, remember, in reality, the list goes on and on and on with a lot of attributes about the patient. But for now, for simplicity, I'll just give it an ID, a birth of date, and this makes more sense if I create an object for that. But we're going to talk about that later, or we're going to update it maybe later, and I'll show you how to do that. So I'll just keep a string for now. Let me just put it as age, and I'll just put an integer here. That makes it a little bit easier. Full name, string, and problems. Okay. Now that I created those 4 variables, I'm going to come and start creating methods. Now, the first type of method I'm going to create is called constructors. Now, let me just make it feel same. Okay, so constructors. What is a constructor? Well, a constructor is a special method that has the same name as the class. So I'll just put it that way. And it doesn't have a return data type. And it's basically going to be called every time you create a new object. And in this case, what do I have here? I will, what do I have here? I am going to have a default constructor in this case. What is a default constructor? Well, a default constructor basically, the constructor by itself, let me just state this first, it's the method constructor basically is going to initialize those variables. Let me just put it there. The patient ID, his age, and his full name. Now, I work at a hospital and we got a patient, and that patient, for example, was asleep or he passed out. So I cannot collect any information about him. So I need to put some default values for that patient until he wakes up or somebody will come and feed us with the information. So usually a default constructor is going to be called to assign default values to that patient. Now I do have another patient register. And this is what we call argument constructors. And in the argument constructor, basically what can we do? We can pass information. So I'm going to pass a string for his ID, string, an integer for his age, and another one for his full name. And then after that, I get those information, for example, from the user, from the patient, and he doesn't know what kind of problem does he have, so I'll let the doctor decide what will be the problem later. So this is another method. It's a constructor where I actually have information about the patient, and I'm going to use them to set those values. I can have a method called a patient not registry, sorry. Patient status. And of course, I'm not supposed to have a space here. This is where the information about the patient is going to be printed. And this one is going to return nothing, so void. Plus, now remember here, when you use minus, that basically means it's private. When you use a plus, that's public. So that patient status. What else can we do here? We can decide what is the bill. So let's come here and create a variable money, and we don't take cents, so it's just going to be dollars, for example. We'll go with integer, and that's it. This is basically, well, since the patient is going to be entered here for the first time, he doesn't know what's the money, so we need to have a setter for the money and for the problem later. Let's put this as a problems, and I'm going to create another. I'm going to call it problem, a single problem, and it's going to be a string. I'll just put it here. So this problems array basically is going to list all the issues and problems that the hospital cover, and then one of those strings is going to be basically assigned to that patient that it just entered. He could have heart issues, stomach issues, breathing issues. We'll have a list of all these issues, and one of them is basically going to be assigned to that patient. Now that I have those three methods, what we can do also, we can payment. And this is where we're going to calculate the payments. How am I going to calculate the payments? I'm not sure yet, but I know it should return an integer, which basically the money that let's just put it here as a payment. That makes more sense. Patient payment. Well, that doesn't make sense, so money. So payment, this is how much money the hospital need to collect. I'm going to create another set of methods. We call them the setters. Now, setters are methods that are going to be used to have access to those variables, so you can give them values. Now, just remember, those are private elements. And because they're private elements, you don't have access to them. You cannot change them outside of that function. So if you want to have access to them, usually the setters will give you access to them. But that's not the reason why we have setters. Usually setters will give you control over what value should be assigned to the patient ID, what value could be assigned to the age. You want to have control over all these values, because if you just leave it to the user to decide whatever value is going to be set, you'll have an issue. And I'm going to show you how it works in a sec when we get to there. So set patient ID. Okay, my computer is acting up. And we need to put P as an uppercase. Now, since we try to set the patient ID, so we need to pass the string for the patient ID. Of course, because it's the setter, is going to return nothing, so void for now. Later, I'm going to show you that. What if I don't want it to return nothing? I want it to return something. I'm going to talk about that when we get to the implementation. So we got set patient ID. Well, it makes more sense if I actually use patient with every single variable. But let's just make it simple. Set age. We pass an integer. Remember, return nothing. And we pass full name. Pass a string. Remember, string in Java has to be uppercase, so return nothing. And then we said, well, what else? Set money and problem. Set money. This is how much money he has to pay. Void plus set problem. And we pass a string, and we go void. So that's all the setters. Now, those methods basically will give me access to those variables if I want to have access to them outside of the function. But usually this is not why we do it. We usually have setters to have full control over what value should be assigned to patient ID and what value should not be assigned to the patient ID. I'm going to have another list of methods called getters. So I'm going to copy this, put it down, and just remember we are going to set patient is going to be get. So we get patient ID, we get age, we get full name, we get money, we get problem. And because it's a get, we don't pass anything. So we give them out. We're not going to pass anything to it. We're trying to get the information, not pass anything to be assigned to those variables. And it's going to basically return something. So if I want the patient ID, which is a string, so it's going to return a string. And if I want the age, which is an integer, so it's going to return an integer. And the same thing here is going to return a string. And this is going to return an integer. And this is going to return a string. So here we go. This is the UML. And the UML, I'm going to update it later because those setters, I can make them a lot better than just returning a void. Let's see here. 1, 2, 3, 4. How? Wait a minute. Patient. Wait a minute. Here's the setters. Set patient age. Print. Okay, here it is. 1, 2, 3, 4, 5. Yes. So those are my setters, and then I have another 5 getters. As I said, this is UML. This is basically what you have to do at the beginning of designing any class to create the UML. Now, this project that I'm using here is basically a simple project, and later on we're going to learn what if I have multiple classes, how do I make all these UMLs and how to make them connected. For now, I'm just telling you here, I am going to come here and change the age maybe later to be date of birth, and I'm going to use a class called date to do that. Maybe I'll get that done in the next video when we move on to talk about composition and an inheritance. So let's just keep that to the next video then. Those are the attributes, and those are the methods. And in the methods, basically, I do have two constructors, and then I have one print method, patient status, that's going to print the method, and then I'll have another method to calculate the payment, and then after that I have setters and I have getters. And now, after I'm done, I need to go and convert this into a code. Now, but before I get into that point, let me just tell you something. This is going to be an array of diseases or issues that the hospital cover. So whenever a patient is registered to a hospital, one of the problems, I'm just going to assume one of them, just to make it simple, need to be assigned to that patient. So what kind of disease that patient has, what kind of problem that patient has. So it has to match with whatever I have inside this array. If it doesn't match, that basically means I cannot register that patient because basically that hospital cannot help him. I need to find another hospital. And that's basically what I'm going to be trying to implement when I move to Eclipse. So I will stop at this point, and then now I'm going to be moving on to Eclipse to continue with the process. So I'm back. Now let's go ahead and try to convert this UML into a class. So the first thing we need to do, of course, we need to open the Eclipse. And then from here at the file, you go and click on New Java Project. And I'm going to call this one Lesson 1. And go finish it. If you want to create a module, I'll say do not. Now that I have Lesson 1 created here in my Package Explorer, I believe, or Workspace, you click on this arrow here to extend it. You go to Sources, SRC, and you click on this. And I'm going to create two classes. The first one, you pick a class here. The first one, I'm going to call it Main Class. And I'm going to make sure to choose this option here to create a public static void main method. And should open here in a second. Here we go. So this is the main class. This is the public static main method. And I am going to leave this at this point, as you can see here. Now what I'm going to do, I'm going to come back here and create a new class. And this class basically is going to be our patient registry class. So let me go back to the file. I'm going to copy the name of the class. I'm going to put it here. And this time, make sure you do not choose public static void method. And here we go. So this is my patient registry class. Now, in the list of UML here, I do have all these data types. So what I'm going to do, I'm going to copy them. And of course, it will be very helpful here if you come and put some comments about your name and project and then let's say date, some details to document what you're doing here and the purpose of this project, of course. Now I'm just going to leave it empty, as you can see here. In this area, this is where we're going to declare our variables. Of course, it's going to give me errors. The reason I'm putting this here so I don't forget anything, I'm going to delete this in a sec. Let me just go ahead and put it as a comment. Okay, now what we need to do, we need to create a patient ID as a string. So we start with the keyword private, and then we decide what will be the return data type, which is going to be a string, and then we're going to call it patient ID. Let me copy this, put it here, put a semicolon. Right after that, we're going to create another private item. This time it's going to be an integer, and we call it age. I'm going to talk about why do we create those variables as private right now. The reason we do that because we want to keep, again, if it's private, that basically means people who are going to use the main function, which basically are the users, will not have direct access to them. They will not be able to modify it. We will have control over modifying it, and I'm going to show you how we have that control. So let's keep going now. We have the full name, which is again going to be private string. So let me copy that, put it here. Now we'll call it full name, semicolon. And we have the money, private. I don't like the name money. I can't think about a word for it. So integer, if you have any better term, please feel free to change it. And then we have a problem. So it's going to be another string, problem. Now we have a special string here, which is an array of problems. And we said this is going to be static. So static private. What did we say is going to be called problems? And it's an array. Oh, I'm supposed to define the data type. String. And then let's assign a list of problems. And I am going to go, for example, heart problems. Let's go with lowercase h. He doesn't like it that way. Let's try to remember, how do we create a string of arrays? Well, I remember now. Heart, head problems. Let's say blood problems. Head, blood, heart. I'm not a doctor, so I'm not really aware of what kind of problems people have at hospitals. Let me just talk about myself here. What do I have? I call it sugar. It's not sugar. Blood, head. Yeah, let's go. Body. Vision. So we'll go eye problems. Again, just remember this. The whole point here is not to. The terminology is not my biggest concern now. It's just to represent those variables. So those are the types of problems that this hospital actually cover. Heart problem, head problems. I don't know what head problem is. Blood problems, body problems. By body maybe muscles. That's what they. And eye problems. Let's just keep it that way. So I'm going to move this away, and I'm going to keep it. So this is basically my private section of my class. Now we're going to have to move on to the public section. And with the public section, I do have all these methods here. Now, the good news, well, let me start with those two. Well, before I do that, let me start with the setters and the getters. Let's just keep it that way. That makes it a lot easier. So I'm going to come here, and this is how cool Eclipse is. You right-click on this, and you go to Sources, and then you click on Generate Getters and Setters. Let's just select Getters, and then you just click on Generate, and you'll see here I got all the getters. Get patient ID, get age, get full name, get money, get problem. Well, since this is a static, I don't want this actually. I can take that away. Well, actually, maybe I can have it. No, I don't need it. Let's just take that away. If I go back here, did I have a get problems? I just have get problem one time. Okay. Now let's go into setters. The setters basically is going to give me a default implementation, but I'm going to have to change it by myself. So let me just put here, wait a minute, okay. I'll say getters. I'm going to go all the way down here. So this is how I distinguish it. And now let's start creating the setters. And then after that, I will go create the other methods. And let me put some space between them. Now for the setters, just like we did before, right-click, sources, get setters and getters. We say select setters. I'm going to take this away. I don't want to set that static variable. So generate and wait. Oh, did I click cancel? Oh, here it is. Oh, this is getters. And here's setters. Get, set. Oh, I did it in the wrong place. So I'm going to go ahead and cut those from here. And I'm going to paste them here. So let me just make sure that we got set the patient ID, we pass the patient ID, set the age, we pass the age, set the full name, set the money, and set the problem. Okay. Now, let me just say, I will keep this as a default implementation. I will modify this one here. I'll put a question mark. This needs to be modified. Full name will not be modified. The money has to be modified. We'll came up with a scenario about how the money will be calculated. And the problem basically is going to be, I have to modify it actually. So let's just keep it that way. I am going to update this, and update this in a sec. I want to have control over what kind of values is going to be assigned to those variables. Now that I'm done with the setters and the getters, not really done with the setters and getters, I can come at the top here and create the constructors. Let me just go back to the UML and see what we have here. We have the constructors, we have the patient status. Well, you know what? This patient status, I am going to change it. I'm not going to keep it. I am going to change this to be what we call, and I want you to pay attention to this. Well, you know, let me keep it for now. Later I'm going to show you why I need to change this. So we do have all these 4 methods that need to be implemented, and the rest are setters and getters. So I'm going to copy them. I'm going to go back here. As you can see here, once you create your UML, the process is not that complicated anymore. I'm going to put them here in this area. And as I said, I am going to change them. I'm going to implement those methods in a sec. So let's start with the first one, which is the default constructor. And now it should be public. Doesn't have a return data type, and this is where you do the implementation. Now what I'm going to do, I'm going to set default values for all these variables that I have. So to do that, what I'm going to do, I'm going to come here and type this dot set. Let me see here why he doesn't like the dot. It should be arrow. Nope, this is not C++. Set. You know what? Let me just copy it. Oh, I remember my Eclipse is a little bit old, so that's why it doesn't like it. Here it is. Set the patient ID. Dot. Set patient ID. It's dot, not comma. And in this area, you have to pass the student ID. I'm just going to say unknown. That's basically the patient ID that I'm going to set, because again, I don't know any information about this patient, so I'm going to go use this. Now, here's the thing: I can actually create and call this function without using this keyword, but I highly recommend using this keyword every once you have a chance. This is basically telling you that if I created a patient using the patient registry default constructor, so this here keyword belonged to that object that I just created, the one that I have no idea any information about him. So set full name, we'll just do the same thing here. Semicolon, unknown, copy that, put it here. And we have set age, so this dot set age. And by default, I'm going to assume that since I don't know his age, I'm going to put 0. We'll just put 1. That's my default value for setting the age. Let's see, we got age, we have full name, set money. Since I don't know anything about money, I'll assume that we will charge him $30 for just getting inside the hospital. And then set the problem. Copy that. I'll just put it here. And let's go with this. Set problem. And I'll just say unknown again. Because again, he just entered to the hospital. He was, let's see, he passed out. I can't get any information from him, so we don't know what's the problem. We don't know anything, so we'll just put those default values for that patient. Now what I'm going to do, I'm going to copy this. I'm going to put it here. Now this time I do have information, so it's not going to be just that. So string, and I'll just call this one ID. And here I'm going to put ID, so we got that part covered. Now full name, string, let's call it FN, and you come here and you change this to be FN. Now what is FN? We're going to figure it out when we create the object. Age, I'll put Y, and I'll put Y here. That's how old is he? He's Y. We'll see what exactly is Y. Now he doesn't like that for some reason. Let me see. What did we call it? We call it age. And here it is, age. Why are you complaining? Well, let's keep going and then we'll see. Oh, sorry, integer. Integer Y. My bad. And then money, so integer M. Well, since I can use $, let's just put $sign here. And I'll come here and put $M. I'm allowed to do that in Java, actually. And the problem, we'll go string, we'll just call it P, and we'll put P here. Or actually, you can put it as a problem if you want. Yeah, problem. Let's do that. Control C, and let's put it here. Problem. ID for a full name. Okay, now this is my default, my argument constructor. So I got this done. And now we need to patient status, which basically this is how we're going to print. So it's going to be void, not returning anything. It's going to be public, so I can have access to it. And it's going to be called this. Of course, I made a mistake. It has to be public void, not void public. Now, this will work, but there's a better way, and I'm going to show you that better way after I'm done with everything. So, system.out.println, this is basically how we print information, and I'm going to show all his status. So let me just copy this. How many variables did we create for that patient? We created 1, 2, 3, 4, 5. So we need 5 of those print statements. We'll just put ID and then plus. Let me copy it. And we'll put it here. So the ID is going to be printed on screen. And then after that, the age. Of course, I have to put it between double quotations. This is just going to be it. And let me put a space here. And then we'll just go ahead and what did we call it here again? Age. So we'll just go ahead and put age. Oh, of course I forgot something. You can put this dot age. This dot age. Okay. What is the third one? It's a full name. Let me copy that. Go down and put full name plus full name. And of course, again, it's recommended to use that. And then after that, we have the money. Let me charge. Plus money. This is how much they're going to charge you. And then after that, and you know what? Let me put a $sign here so it will look like money. Now, I don't remember this exactly, but there is a class. It's related to currency that can convert your variables into a money. So, for simplicity, I'm not going to go through that, but if you want, just go ahead and search Java for currency processing, and basically what's going to happen, it's just going to, when you have cents, it's not going to show you, for example, 3.75670.8 cents. It's just going to show you the first 2 digits after the decimal point for the cents, and rounded it up. So this is the money. What else do we have? We have the problem. Let's put problem, and then we'll just go ahead and say this dot problem. Okay, so here we go. This is basically going to print all these values. Now, we do have one issue left, is basically how am I going to calculate the payment. So this basically is going to return an integer. So public integer, and what did I call it again? Payments. Well, it doesn't make sense to call it payment, but let's just go ahead with that. I'm supposed to calculate the payment here. Now, before I do anything, integer payment, it's complained because I don't have a return statement, that's why. We'll get that figured out. Now, let me just go ahead and fix those setters before I get into the payment. Now, age, here's what I'm going to do. I'm going to say if age is less than 0, negative value, or age is greater than, well, how old a person can get. 150? Well, let's say 200. That's impossible. If that patient was less than or, so any of those two cases, we're just going to have to actually show a message. And what is it? System.out.print line. I will just say, this is invalid entry. Please set the age again. So basically I'm asking him to call the set age function again. And what I'm going to do here, I'm going to go to the age and set it to 0 or 1. That was the default value that we picked, right? Yep. But you know what? I don't think I need that. I'm just going to come here and say else this dot age equal age, and this is a perfect place to use this keyword. This basically means the age we're talking about with this is this one exactly, the data member, and the other age here is basically the argument, which is this one here. So I got this age covered, and as you can see here, I did what I did here so I can have control over what kind of value should be assigned to the age. And I said any value less than 0 basically means negative, or anything that's greater than 200 should not be acceptable. So I'm just going to go ahead and set, well, you know what, let me just come here and do this. What if he did that mistake? So I'll just set the age to equal 0. And by the way, if I don't do that, by default the compiler would do it for me. So you don't have to worry, but just to buy some insurance, I'll just get it here. Set it to 0. I'll show you if I take it out, what's going to happen. If I keep it, what's going to happen. So I'm going to put a question mark here to see how exactly Java will handle variables or data members that's not going to be assigned to values. Basically, by default, I know that this is my default constructor, but there's another default constructor that's going to be generated by Java itself to set all these values to default values, just in case you decided to not assign one of the values in your default constructor that you created as a programmer. Okay, so I got this part covered. Let's go ahead and talk about the money. Now, before we do the money, let's do the problems. What I'm going to do here, I'm going to ask this question. If, I'm going to put it here, problem dot equal ignore. Now, I hate this. My Eclipse doesn't actually complete it for me. So it's a kind of long statement to write. What I'm trying to do here, if the problem that was passed is basically unknown, that basically means I have no idea what it is, then yes, just set it to unknown. Otherwise, I need to compare the problem that has been passed to one of those. If I found a match, then keep it. If I didn't find a match, I'll ask the user to go and find another hospital because we don't cover that problem. So let's go ahead and do that. I need to do Google in a sec. So let's go ahead here. Java equal ignore the case. I just want to make sure that I'm not missing or misspelling something. Equal ignore the case. Here it is. Ignore case. I knew it. There's no that. And in this area, I need to put, what am I going to be comparing to? Unknown. Of course, if you have any other options you want to check, you can just put an OR here and check any other terms for unknown in this area. Now, just to remind you of something, in Java, we are not allowed to compare strings directly. Like, you cannot say problem double equal unknown. We cannot compare strings in Java directly using the double equal operation. If you don't know why, go and do a research, because basically the double equal in Java, whenever you have an object in both sides, basically Java is comparing, are those two objects referring to the same memory space inside your memory system or not, and instead of actually comparing the values themselves. So in Java, whenever you want to compare two strings, you have to go with equal or equal ignore the case. So if that's the case, well, here's what I'm going to do. I'm just going to say problem. Oh, this problem. I'm just going to take it as it is. This dot problem. I can easily fix this problem by adding unknown to, where is it? To the problem set, but I'm just going to make it a little bit different. Problem, this problem equal problem. And if that's my first case that I'm studying here, else, well, this is going to be a little bit long, else, I need to have an if statement. Well, actually not an if statement. I'm going to have an if inside. Let me just go ahead and fix this. So I got this if statement, and then I have an else for it. Let me take this away. And in this else statement, I'm going to check if the problem matches with one of the problems that I have in the problems array. So where am I? Here I am. I don't need this here anymore. Let's take that out. And my job here is to compare the problem that I pass here with the problems that I have in this array, the problems array. And if I find a match, print it on the screen, and you're done. Otherwise, so what I'm going to do, I'm going to say for and I'm going to come integer I equals 0. I is less than, let's see here. I call this problems. Where is it? Problems. Now I need to know how many elements do I have in this problem. Of course, I'm not going to go with magic numbers and say 5 I need to actually calculate it. So what I'm going to come here, I'm going to say integer size equal problems dot length. Let's see if he likes it. He actually looked like he likes it. I am not sure if I have to put a parentheses or not. Nope. That's, again, different Java than C++. So I'll just go ahead and put size here. And then I'll go I++. Now, my job here is to look for a match. I want to find out if the problem that I pass here will match any of the problems that I have here. So, let's see here. And, yep, so I'm going to have to put an if statement here, just like the if statement that I have here. So I'm going to come and copy this. Oh, look at this. Problem that I pass here is going to be compared to unknowns. Okay, that makes sense. So that's exactly what I want to do. So I am going to copy this, but I'm going to make it a little bit different. So I'm going to put it here. I keep problem as it is, but instead of unknown, I'm going to have to compare with problems of I. So I'm going to compare a problem here with the first one and the second one and the third one. And again, ignore the case. If you find a match, what do we do? Well, if you find a match, immediately assign the object variable problem to problems. That's very important. And then get out, return. Return basically means leave this function. You are done. So you're going to keep going, matching, looking for a match, looking for a match, looking for. The moment you find a match, you're going to set the problem variable for the object to the problem passed here, and then after that you leave. Now, what if that's not the case? If that's not the case, you need to tell the user that there is a problem, that the problem that you pass here as an argument doesn't match with the cases that we covered. So we just need to set the problem to a value. Well, let's see if we need to actually set the value. I'm just going to terminate the program, the program at that point. Not necessary. Let's go ahead and do that. System. And just remember, this is it gets a little bit complicated when you have a lot of parentheses. So I'm going to take this one away and this one away. So we know that we have this else statement here. So this here is for the function itself. This here is for the else statement. We got 1 and I got 2. So here we go. 1 here, 2 here, 3 here, and 4 here. Okay, now I am still inside. No, I'm not supposed to be inside the for loop. I'm supposed to be outside of the for loop. So I'll go here. Remember, this is the end of the for loop. I'm still inside the else statement. Let's go ahead and system.out.print line. We cannot help. That's basically the message the patient will see, and after that, we'll just set the problem to equal, or let's just go ahead and call the problem setter. Is that the setter? Yeah, that's the setter. We cannot call it again. We'll just go ahead and set it. This dot problem equal. And what am I supposed to set it with? Unknown is basically, if I don't know it, basically, I'm just going to set it to no service. No service. No service available. No, that's not how you spell available. 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 Okay, so here we go. This is basically, now this brought my attention to something. What if the patient doesn't get served here? Because the problem that's covered here is not actually, the problem that he has not listed here. I need to have a Boolean variable for that to make sure that I can check if the patient um, will be charged or will be actually, he will always be charged, but again, since we couldn't help him in this hospital, so he's just going to have to leave. So I'll just keep it simple for now. And if you want to do that, you can basically come here and add um, a Boolean variable, and that Boolean variable is going to be set if a match happened. We'll just keep it simple for now. Okay, so I got this part covered. Let's go to the money section. Well, here's what I'm going to do. Depending on the type of the problem, if the patient has a heart issue, he's going to be charged $1,000. Well, no, $100,000. If it's a head problem, he's going to be charged $10,000. If it's a blood, $5,000. If it's a body, $1,000. If it's eye, $5. That's my pricing in my hospital. So I need to set the money based on what type of problem the patient has. And, well, since that's the case, we need to set the problem before we set the money. That's a very important issue here. And look at the money here. We're setting the money by default to 30. Now, this is going to be a problem. And this is going to be another problem. Since we want to set the money based on the problem, the setter should not be a money. I don't want to set the money to a default value decided by the nurse. I want the system to decide how much I'm going to charge that person. So I'm going to set money, and I'm not going to pass values actually. Let's take that out. And I'm going to take this out as well. I'm not going to pass money. And I have to go to set money. Where is set money? Set money. Here it is. No money will be passed. It's going to be assigned to a value, but we're going to figure that. And the payment. Well, as you can see here, set money and payment are basically very similar. So I'm going to set the payment, and when it comes to the payment, I'm just going to call that function. Let's go ahead here. This is basically how we're going to set the money. I need to have a for loop, just like the one that I had here. So I'm going to copy this. This is the for loop. This is an if statement. So let me copy this. And I'm going to come in this area. Now, one very important thing, since the money basically depends on the problem, so I need to actually call it after I set the problem. And same thing here. You know what? I do have a better idea to make it a little bit easier. Of course, I still need to define the size. So this is redundant. It will make it a lot easier if I just have a static variable to decide what is the size of it. But I don't want to make this video longer than it is. So let's just go ahead and do that. So set the money. I'm going to go through a for loop, and if the problem, I need to pass the problem here as well. And instead of passing nothing, because the money is going to be defined by the problem, so I need to pass the problem. Okay, it's getting a little bit more complicated than I thought it would be, so let's go ahead here and do that. Copy this, put it here, go away, and do the same thing here. I'm passing the problem because the problem is going to define how much payment he needs to do. Okay, so I got this part covered, and now I need to go to set money and pass the problem. Okay, so what we're going to do, we're basically going to, okay, why is he complaining? Because it has to be a string. Okay, so if a problem is matched, here's what we're going to do. We're going to say, let me just take this away. this dot money. Now let me just make sure that I didn't change it. Yeah, here it is. This dot money. Where is it? Here it is. Equal. Now, how are we going to charge that person? What are the mechanisms that I'm going to use? Well, depending on the value of I, it's going to be I plus 1. So basically, if it's 0, which is a heart, I'm using the index, the location of those diseases to decide the value of how much I'm going to charge him. So this is 0, this is 1, 2, 3, and 4. I'm adding 1 to it, so it's going to be 1, 2, 4, 5. So where is it? The whole thing is going to be multiplied by a number of my choice. And I'll put, okay, now this makes it a little bit, the further you are in the index, the more expensive it will be. So let's just go ahead and put 100, and then it's going to be 200. So let's make it 1,000. That makes more sense. So that's basically how much money the person is going to be charged based on the problem that he has. Now, what if I didn't find any match here? Well, I need to set the money to equal 30. That's basically how much I'm going to charge if I don't know. Now, this is a magic number, which I'm not supposed to do. So what I'm going to come here and do this. I'm going to come at the top. Well, you know what? Let me just fix this. As you can see, I'm updating the UML. So if I'll need to go back to the UML and change it if I want to. Let me come here and do this. I'm going to go static, final, integer, default charge. And let me put an underscore here. I'll set that to 30. The default charge. Let me copy that. And this is just to show you an example that you are not supposed to use magic numbers. The default charge. So basically, if there's no match, he basically is going to be charged with a default charge, which is at $30. So that would be number 1. What else? Now, I said here the size, where is it? The size here variable that I'm using here, it will make more sense instead of repeating the calculation in each one of those methods, is basically to have a method for that. So what I'm going to do, where is it? I'm going to keep it. Oh, wait a minute, this is static private. I need to actually keep this as a private as well. Now the question is, why did it complain if I didn't put it private? Because everything by default is private. Now, let's say here, I want to create another static private method. Static private integer, and let me see if I can actually do this. I want to make it as final. By the way, final means a constant variable that will not change. Final integer, and I will just call it, do I need to call that method? No, I just want to have a variable. Final integer, yes. And I will call it size. And size equal, let me just come here all the way to the bottom. Where is it? Where is it? Where is it? Where did I calculate? Problems.length. And let's see if he's going to take that and accept it. Yep. So I do have a variable now. It's private, it's static, it's final, and it's integer, and it's called size. Now what I need to do is, every time I use size, and instead of lowercase, put size uppercase, and I don't need this line anymore. This is set money, and the same thing here, I don't need this anymore. And let's put here size, S-I-Z. Okay, now that I'm done with those, what I can do here, I still have the payment method. Well, guess what? Payment method basically means just get money. This dot, and call get money and return whatever the value that you're going to get and make it public. So I believe I am done with implementation of all these setters and the getters. Now what's left is to give this a try. I'm going to try to build it. Let's see here. Where is it? Run. Build, 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 build. I'll have to run it too. Okay, go ahead. For student ID, enter. Oh, look at this. It's going back to a project that I created a long time ago. Nope, this is not what I want. Run it again. Dear Lord. I think I need to come here to the main function. He's running another main function, and I think if I click on one of the arrows here, I should be able to fix this problem. He's basically running one of those examples that I have here at the top. Here it is. So see, those are basically what's going on here. How do I clean this? Run as Java application 1, run configuration, favorite, no. Configuration, no. Okay, I'm going to close this. Let me just create objects. I'm going to start with the process of creating an object. So to create an object, basically, you need to start by typing the class name. And then you give it a name. What am I going to call it? I'm going to call it patient 1 equal new class name, and you put parentheses. This is basically will create what we call a default patient. Basically, a default constructor is going to be called. Okay. Now let's create another patient. Patient 2 equal new pay. Well, you know, let me just. And now I need to pass arguments. Now, first of all, we said we have the ID. So you basically have to follow the exact order they have here. I got ID, which is a string. So I'm going to come here and type 1, 2, 3. And then after that, I have the name. I will call him Adam Smith. He's my favorite chef, by the way. And we have his age. I'll give him a 36. And what is the third one? It's a problem. Well, I'm going to try two different registers. The first problem, I'm going to put heart, which basically does exist in the list. And let me copy this. And I'm going to go and test all the possibilities. So, for example, Adam Smith, I'm going to call him Adam Steve this time. And I'm going to give him a 300 years old. And I'm going to put the problem as, let's say, hand problem, which doesn't exist. So the age is a problem here, and the hand is a problem here. That we don't cover hand, and we don't cover a patient with 300 years old. Okay, now let's go ahead and let's change this to be patient 3. I'm going to try to print the values for each one of those patients. So patient, let me just copy this, Control C. Patient 1 dot, what did we call the function that will print the values? Print status. Now, if you download the latest version of Eclipse on your machine, you don't have to go through whatever I'm going through right now. The Eclipse should be smart enough to show you all the functions that you have access to. So I'm going to copy this, put it here, and put it here, and I'm going to change this one to be 2, and this to be 3. So we know that this first one basically have no information about him. The second one, I do have everything about him. It should be fine. The second one, I have 2 problems, the age and the hand. Let's give this a try. Okay, let's go from the top. Okay, this is invalid entry. Please set the age again. Okay, we cannot help. Well, this is for patient 1. I need to make sure that I understand why did I give those. Unknown 3, problem unknown. The second one, ID 3 Adam Smith, 1,000 exactly because it's a hard. And the second one, Adam Smith. Okay, I see what's going on here. No service available. Those two those two messages are printed because of this patient number 3. Okay, you know what I'm going to do just to make it easier? I'm going to have to go, because when I printed it this way, immediately I thought that those error messages are related to patient number 1. So what I'm going to do, I'm going to go to those places where I made the mistakes. I'm just going to use the name here. So let's go ahead, system print out. So you basically have an idea which patient for, and I'm just going to go plus, and I'll put a full name. And I'm going to put this, of course, here, because I like that. And I'll put semicolon. For Adam Smith, blah, 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 this is going to be a problem. Let me just go ahead for the other problem, or we cannot help. And I'm just going to put it this way as well. Let me run it again. And you can see here, for Adam Steve, this is invalid entry. Please set the age again. From Adam Steve, just like we did, we cannot help. And as you can see here, everything goes smooth. Now, let me just go ahead here and change the hard to be I. Now, remember I in the order, or is it? I is here, so basically this is 1, 2, 3, 4, 5. He's supposed to be charged for $5,000 to fix his eyes. Well, this is the one that doesn't have anything. Here it is. Adam Smith has an eye problem, $5,000. Again, programming is a little bit more complicated than what I'm doing here. I'm just trying to make it fast and simple. But again, if you think about it, if you just go and look for the terminology, the right terminology, and you really pay attention to the details of the problems and the payment and what kind of terminology they use at hospitals, it will make it looks a little bit more professional than it is right now. Okay, now, the last part I want to talk about here, well, actually 2 parts. Number 1, those constructors, where is it? Here, this is the constructor and this is the constructor. And let me go back here. Those 3 patients that I created using those constructors. Now, if you want to learn C++ in the future, you will know that whenever you have a constructor, you need to have a destructor. And the job of the destructor is basically, with object-oriented programming style, whenever you create an object, the space reserved in the memory for that object is going to be in the memory, even after you terminate the program. That's in C++. Now, with C++, basically what you need to have a destructor to free that space after the program is terminated. Now, a lot of people forget about the destructor because they don't see errors, but actually there will be a reserved space inside the memory, and you basically need to turn your computer off and on so you can use that space again. For that reason, people who created Java thought about, since people always forget about the destructor, here's what I'm going to do. Well, let me make this one 5. I'm going to create a program, and I'm going to call that program is a garbage collector, which is going to be part of your project. Whenever your program gets to the termination of it, at the end of it, basically the garbage collector is going to be called, and the garbage collector is basically going to go ahead and look at the memory, this reserved space inside the memory for your program, and clear it up for you so you don't have to worry about that. So that's basically what garbage collector is. Do you have to worry about garbage collector? No, you just need to know about it, just in case somebody asks you about that. Now, the last part, which is the last part actually, we have a special function called toString. And now look what I'm going to do. You see this patient status here? This is basically going to print the information. Now look what I can do. If I come here, and let me just copy this, and I'm just going to go system.out.print line, and I'll just put patient 1. Now, I'm going to comment this one because it has issues, and this one, and this one, and this one. What I want to see what's going to be printed if I just put the name of the object here. And look what's going to happen. Oh, you can see here, patient registry at, and this hexadecimal number. Now, what does that mean? Basically, this patient 1 is an object. an object that belonged to a class called patient registry. So it's going to tell you what is the name of the class that this object belonged to. And this is at. What does that mean? Basically, it means this patient object or patient register object is stored at a memory location with this address. So if you try to print an object, it's going to tell you where is it stored inside your memory. Well, what if I wanted to actually print the exact same information that I have here? And instead of showing me the address of it, well, here's what we can do. And what I'm going to do right now, I'm going to comment this part. And I'm going to create a very special function that you need to be aware of, and you need to know it. And you're going to be asked about it. And it's used a lot. We're going to override this method now. If you don't know what's overriding, we're going to explain that in the next video. So let's just go ahead and do that. I'm going to get back to this, by the way, later. So it's going to be public. It's not a static. It's going to return a string. So uppercase S, string. And this function called toString. Now, what do I mean by overriding it? Well, by default, there is toString method inside your class, but you don't see it. And it's not implemented. It's empty. So actually, it's not empty. That toString method that already exists in your class that you don't see it basically is responsible for returning the address. Now, what do you need to do? You need to change that implementation. I don't want it to return the address. I want it to do something for me. And here's what I'm going to do. Return. Oh, you know what? I'm going to create a string. It's going to be a long one, by the way. I'm going to call it str, and it's going to equal. And I want you to pay attention to what I'm going to do. I'm going to copy this. Copy it. And you put it here. So I'm creating a string. This patient ID, of course, he's complaining about the semicolon. And then after that, look what I'm going to do. I'm going to put a plus. And I'm going to put backslash n. And then I'm going to copy this. Well, backslash n. Why is this here? Okay, take that out. And then I put a plus. And then I'll do the same thing here. Let me just copy this for now, and then I'm going to update it. Copy this. Put it here. Now let me take this away. Take this away. And you come here and you put backslash n. Now, you may ask, what are you doing here? What I'm doing here, I'm creating a new string. I'm calling it str. str basically is going to be everything you see here in those print lines. Now, since I have multiple print lines and they go underneath each other, so after you're done with the first, for example, the ID, you want to go to the next line. So backslash n is a skip character that's going to move to the next line. And then you get me the age. And then you get the full name. Now you come here. What do I have after full name? I have the charge. So I'm going to copy this. And I'm going to go here, plus, and put it here. Now you need to come here and put backslash n, so it goes to the next line. And then you come here. What did we have after the money? We have the problem, so let's just copy this. I promise you all the problems that you see here is going to be fixed in a sec. So problem, you put a backslash n again, and you go to the problem, and you put a semicolon here since I'm done. Right after that, return str. That's basically what I called. And now it's gone. So what I did here, I created a method called toString, and I'm going to override an original method that's called toString that's available in my class. I'm going to talk about that in the next video, just in case you're wondering where's that toString methods are coming from. And I created a string, which basically going to show those values as they are. And now, look at this. If I come back here, patient number 1, let me run it, and look at this. It works perfectly fine. Let me put 2. And you can see here, ID 123, age 36, Adam Smith, 5000, I. Put 3. Oh, 3 is not going to work because of this. Let me take that away. I'm going to put 3 here. And as you can see, first of all, it shows you the errors that occurred by the age and the problem. But again, here we go. The age is 0. That's the one that we set it to. Yeah, and then the charge is going to be 30, and there's no service available. Okay, so let me just go back here to make sure that I didn't forget anything about the video. So we talked about this, getters, setters, constructors, toString method. I'm going to talk about the arrays of objects, garbage collector, and libraries. Now, I'm going to get back to this in a sec. I talked about the garbage collector. Java, as I said before, came with a huge array library. In this project that I created, basically, we didn't use any external libraries. We used the standard ones. But again, at a certain time, you'll find yourself importing a lot of libraries to your project. For example, if you want to process scanners, arrays, you want to generate a random number, if you want to handle exceptions, if you want to create a date, then basically you need to import those libraries to your project. The good news is you don't need to know what's exactly inside those libraries. All you need to know is just to learn how to use them. Again, I don't want my video to last for 5 or 10 hours. That's why I have to skip this part. But again, in the future, as we go and move through the videos, every time we need to use one of those libraries, I will just show you how to use it. Now, the last part I want to talk about, let me go back here. Instead of me creating 3 patients, as you can see here, I can create an array of patients. So I can come here and do this. Let's just go ahead and do that. Patient registry. I'm just going to call it PAT equal new patient registry, and I'm going to have to set the size to be 3. So here we go. This is me creating 3 patients. Now, if I want to call each one of them individually, and instead of doing it this way, I can come here and take, you know what, let me just comment this as I did before. And let me copy this. Go here, and instead of patient, you just put 0, and you called that one. Let me copy this one here. Control-C, put it here, copy this, and put it here. And you come here and just copy this part. Patient 0, patient 1, patient 2. So there's going to be 1 and there's going to be 2. And now, instead of patient 3, just put patient of 2. And let's run it. Let me put 1. I don't like the third one. And you can see here, oh, wait a minute, Adam Steve, he's still showing me the errors of the first one, which it should not. PAT, let me just start with 0. Oh, of course, yeah. He's basically, because of the, let me just take this one away. And again, no, let me put 1 here. You'll see that the regular one now, since I do have this one that's producing errors, then you basically will be able to see the errors first, and then you'll see his status. This will summarize everything about this video. If you have any questions, leave them as a comment, and wait for more. I am going to make another video probably in a week and post it. Thank you for watching, and have a good day.